So, hello friends, welcome to Informational Compass to our channel. So, today we'll be discussing the solutions of the famous book related to linear algebra, that is, linear algebra and its applications. It has been authored by Gilbert Strang. So, we'll be starting with the first chapter, that is, Matrices and Gaussian Elimination. For that, we'll be starting with the first exercise that is named as 1.2 problem set. So come on, let's start. So our first question is for the equations x plus y is equal to 4 and 2x minus 2y is equal to 4. We have to draw the row picture, that is two intersecting lines, and the column picture, that is the combination of two columns equal to the column vector 4 comma 4 on the right side. Yes, so I've already drawn and I've taken the screenshots so that you will be able to understand this in a much more better way. Yes, so this is the row picture. Which has been constructed. So here, so the solution is, we have to draw the row picture and the column picture. So first, row picture. So in row picture, what does it infer? 2 points define a line. So here if we see, the 2 points for each of the line are, that is, for line x plus y is equal to 4, we have the points as, if we see, it is, yes, 0 comma 4 and 4 comma 0. Yes, so the points are 4 comma 0 and 0 comma 4. Similarly, the 2 points for the line 2x minus 2y is equal to 4 are, they are 2 comma 0 and, yes, and 0 comma minus 2. Yes, 0 comma minus 2 and 2 comma 0. Okay, so these the two lines, that is x plus y equal to 4 and 2x minus 2y is equal to 4. The two lines, they intersect at the common point, that is this point, that is 3 comma 1. So this is a row picture. Now for the second part, that is the column picture. I've taken the screenshot so that would be easy for you. So we have column picture. So what does column picture infer? In column picture, we have to basically depict the combination of two columns equal to the column vector. And what is the column vector? Here, yes, because we have the equations as x plus y equal to 4 and 2x minus 2y equal to 4. So the column vector is 4. It will be written as 4, 4 in this way. So hence what we get, the column picture as x into 1, 2 plus y 1 minus 2 equals 4, 4. Yes, are we able to do this based on the equations? Okay, so therefore we have to find out such x and y which satisfy this equation. So that is 3, 1, 2 plus 1, 1 minus 2, which is equal to, if we calculate this, it will be 3 and 6 plus 1 and minus 2, which is equal to 3 plus 1 and 6 minus 2. which is equal to 4 comma 4. So hence we are able to get x is equal to 3 and y is equal to 1. Yes. So the final answer is, if we write the result, what we basically had to find that what is the value of x and what is the value of y. So this is the solution of the first question. Okay. So now we'll start with the second question from exercise 1.2, question 2. So what the question is given, we have to solve to find the combination of the columns that equals b. Okay, so we have to find the answer in terms of b. Am I right? Okay, so the given equations are I shall write here itself. This is equation 1, this is equation 2, and this is equation 3. Yes, so what I'll do is I'll use equation 3 in equation 2. So using equation 3 in 2, we get, what do we get? We get v plus b3 is equal to b2. This was w, right? So therefore, what is b equal to? B is equal to b2 minus b3. So this is our fourth outcome. Yes. Now we'll use 3 and 4 in 1. So using 3 and 4 in 1. Results. What does it results into? It results into u. Yes. We'll first write it as u is equal to b1 plus v plus w. Okay, so what is v equal to? b2 minus b3. And what is w equal to? b3. Yes, so this gets cancelled. So here we have b1 plus b2. Okay, so we have reached the final result. What is it? So thus the system generated as, this is what we had to find, right? In terms of b. Yes, what do we write? Yes, we write it as u, right? We are going to write it as in terms of u plus v plus w. Yes, so it's b1 plus b2 and nothing downside, plus b3 minus b2, b2 minus b3, 0, plus minus b3, b3 and b3. Yes, so this is equal to b1, b2, b3 enclosed as a system. Yes, so this is the solution of question number 2. Now we will solve question number 3 from the same exercise. So describe the intersection of the three planes, all in 4 dimensional space. So is it a line or a point or an empty set? And what is the intersection if the fourth plane, that is u is equal to -1, is included? And find a fourth equation that leaves us with no solution. Okay, so there are paths. So what we'll do, we'll write as, just a minute. Okay. So our solution is, for the first part, we will write these equations. write the equations. So I'll just write them one below the other. 1 plus v plus w plus z equals 6. Then the second one is u plus w plus z is equal to 4 and u plus w is equal to 2. So we have equation 1, 2 and 3. Yes, so now what we'll do is we'll subtract. Okay, subtracting 3 from 2 and then from 1. Yes, I'll do it together. So we'll get what we'll get from the first outcome. We'll get v plus z is equal to 4. Yes, basically we are subtracting 1 from 3 from 1 and 3 from 2. If I write here, so it is 1 minus 3 and 2 minus 3. This is what we are doing. Okay, so first outcome is v plus z is equal to 4. Second one is z is equal to 2. Yes, very good. And this one is u plus w is equal to 2. Okay, so this is what we get. I'll just 1, 2, 3. Okay. And now again what we are doing is we are subtracting 2 from 1. Subtract 2 from 1. So what do we get here? We get v is equal to 2 first of all, then z is equal to 2 and u plus w as it is. So this is 1, this is 2 and this is 3. Okay. Now what is left? Dependency. So here we can see that only dependency which is left is u plus w is equal to 2. Am I right? So this concludes, this infers that it is a line, yes, in 4-dimensional plane. Okay, more appropriately, let's write space. Okay, now second part is we have to include u is equal to -1. If we include u is equal to -1, by that what we'll do? By that we will eliminate u from the last equation. Yes, and get u is equal to -1, then v is equal to 2, w is equal to 3, yes, and z is equal to 2. So this basically is a dot, which is a dot in 4-dimensional plane, 4-dimensional space, more appropriately, 4-dimensional space. Yes, so we have got the solution. Yes, so what our result will be? Final answer, if you want to write it, the final statement, that first one is without the requirement that u is equal to -1, we have a line. This is our first result. And second is using that requirement, that is with the requirement that u is equal to -1, we have a dot. And both of these results are in both in 4-dimensional space. Yes? So are we clear? So we have solved question number 3. Yes, so now we'll jump to question number 4. So what does question number 4 say? Sketch these 3 lines and decide if the equations are solvable. Okay. 3/2 system. What happens if all the right hand sides are 0 and if any non-zero choice of right hand side that allows the 3 lines to intersect at the same point? Okay, fine. So we'll start with the first. Let us sketch the following lines so as to check whether the system is solvable or not. First, we'll check that. As to check that the system of equations, I'll write the short form. Okay, no issues. Equations are solvable. Okay, so what are the equations? X plus 2y is equal to 2. Second is x minus y is equal to 2 and y is equal to 1. Okay, so first we'll sketch these points. So what I'll do is I'll draw a line. First of all, we'll draw a graph basically, so as to get the idea of what basically it is going to be. Yes. Yes. So now we'll just label them. We'll start labeling them. Okay. So this is 0. Let's label it as yes. So let's label this as 5 and this as 10. Okay, similarly here we have -5 and -10. Okay, they can be extended. Fine. Now here we have 5, 10 again. And again here we have -5. And subsequently, yes, I'll just so we start with plotting. So first one is y is equal to 1. So if these are the 2.5, 2, 1. Okay, so what I'll do is I'll draw it with a simple. A minute, I'll change the color so that you will be able to understand it in a better way. Yes. Yes, so this is our y is equal to 1. Okay, so this is our first equation. Now the second one, we have to solve these two. So x is equal to y, x minus y is equal to 2. So that is y is 0 will be equal to 2. Okay. So what I'll do is I will plot for these equations. So for example, x is equal to y plus 2. So x and y value. If y is 0, x is equal to 2. If y is 1, x is equal to 3. Yes. Y is minus 1, x is equal to 1. Okay, so what we'll do is we'll just plot it. I use a different color for the same. Okay, we'll draw both of these. Okay, now this is for first one. This is a one equation. Second equation is x plus 2y is equal to 2. Now similarly, the way I found out the coordinates, similarly you can do this. So what we get here is 1, 2. So at this intersection, both of these lines meet. So I'll draw it so that you will be able to understand. Yes, so it will be passing from similarly. Okay, and the second line will be passing in this way. I'll just change the color so that you will be able to understand. Okay, so this is what we get by solving these equations. You can extend this if you want. Okay, so this is our plotting of the points. Okay, so we can see that there is no solution for the system basically, since all the three lines, they do not have a common point of intersection. Yes, only these 2 points have some intersection, but here, but not all the 3 points. What we'll write here, that as we infer from the above graph, there is no solution, okay, for that system, since, why? Since all the 3 lines do not intersect in a common point. Okay, but there is one more thing. But if we change the right side, okay, to 0 in all the equations, in all the 3 equations, so what we'll have, x plus 2y is equal to 0, x minus y is equal to 0, and y is equal to 0. then we can get some trivial equation. Okay, then we would have a trivial solution. And what is that trivial solution? X comma y equals 0 comma 0. Okay, what is it? We can be sure that this is the case because it is the only way to find for the first two equations for the system to hold. Okay, so why? What is the reason? This is the case because that is the only way. Okay, for the first two equations of that system, of the system to hold. Okay, that is these two equations. Now for the second part. Okay, this time I'll just draw the graph quickly. Now for the second part. So to find out if there is any non-zero choice of the right hand side and sides so that this system has a solution. So we shall consider x plus 2y is equal to some value a, x minus y is some value b, and y is equal to c. So these are our equations. We have to find that what can be the value of a, b, and c so as to infer that this system has a solution. So what we'll do is we'll substitute 3 in 2 and 1. So substituting equation 3 in equation 2 and 1, we get, in first we get x plus 2c is equal to a, second x minus c is equal to b. So this infers, what does it infer? X is equal to a minus 2c and x is equal to b plus c. So if we equate them, what we get? A minus 2c is equal to b plus c. This implies a is equal to b plus 3c. Yes. So if we take b is equal to 1 and c is also equal to 1, let's say we have the system of equations as x plus 2y is equal to, how much will it be equal to? 4. Yes, very good. And x minus y is equal to 1. Similarly, y is also equal to 1. So this has a unique solution. Okay. Wait a minute. Unique solution. And that solution is given by, as a unique solution, and the solution is given by, you can solve any of these two equations and what we get, the solution is x minus y is equal to, yes, 2 comma 1. Okay, so also if you are asked to draw the graph, so how will you draw? I'll just simply I'll draw it roughly this time. So no. Yes. Okay, just a minute. Just again one more line. Yes, so this is our graph. Now y is equal to 1 will be drawn this way. Okay. This is y is equal to 1. Secondly, again one more line. This will be our second line. And our third line will be equal to want to draw. Minute. It will also pass through this line itself. Okay. So if you want to extend it, you can extend it in both the directions. Okay. So this will be a line of intersection. This point will be, okay, so this point will be the intersection point. Okay. So we have got this. So what will be our final result? I'll write it as a statement so that you can understand this. Okay. So result. So what is the result? There is no solution. First of all, there is no solution for the given system. Yes. Secondly, for the same system but with zeros on the all right hand sides, there is a unique solution and it is a trivial solution. Which implies that is x comma y is equal to 0 comma 0. We can find the right hand sides to be non-trivial and for the system to be solvable. How? One of the example is x plus 2y is equal to 4 and x minus y is equal to 1 with y is also equal to 1. So we have solved question number 4 as well. So if you encounter any doubt, you can let me know in the comment section. I'll explain it. Okay. And until now, if you have not subscribed to this channel, please subscribe it. You will get the solutions for all the questions of this book. And if you need any other solutions for any other book, just you can send me in the comment section or you can mail me. Okay. So yes. So here we have completed question number 1, 2, 3 and 4. Now let's also finish off this question number 5. It's a small one, so we'll be able to do it in this video itself. Okay. So what's the question? Find 2 points on the line of intersection of the three planes t is equal to 0 and z is equal to 0, and the equation in four-dimensional space. Okay. So first, what if we see that any point on the intersection of the three planes has to satisfy equations of all the three planes. Yes. So we are looking at which points do we have to find? X, y, z, t. Okay. In the four-dimensional plane. Okay. So that satisfy t is equal to 0, z is equal to 0, and x plus y plus z plus t is equal to 1. So by substituting 1, 2 in 3. So substituting 1 and 2 in 3, we get what we are left with, x plus y is equal to 1. So hence any point x comma y 0 0 belongs to R raised 4 that satisfies, if it satisfies the condition that x plus y is equal to 1, is the point that lies on the line of intersection of the required three planes. Okay. So such 2 points are, example, let's take an example. So 1 0 0 0 and 0 1 0 0. You can also come up with any other examples also. So what's the final answer? I'll just write it. So the result is those 2 points are x, y, z, t equals 1 0 0 0 0 and x, y, z, t equals 0 1 0 0 0 based on the result we have found. So we have solved question number 5 as well. Let me know if you have any doubt. Okay, and if you haven't yet subscribed to the channel, please subscribe the channel. It's Informational Compass. And if you like the video and you want such more videos, you may please like the video, and if you have any suggestions, you can tell us in the comment section. Okay, thanks a lot. Bye bye, have a good day.